Use the method of cylindrical shells, or just regular shells, to find the volume of the solid that results when the region enclosed by the curves is revolved about the y-axis. All right. So we've got ourselves this shape looking thing created by that line, that curve, enclosed off by 0 and 4. And what we're going to do is we're going to rotate this around the y-axis to create some kind of weird 3D top looking shape that looks like something like that. So as you can see, I'm not a gifted artist, but that's basically what we're getting here. Now, generally speaking, when you use the shells method, all right, when you use the shells method, the way you find the volume is you take the integral where your limits of integration are going to be between a and b, which is created by 0 and 4. So 0 and 4. You multiply, or you take the derivative, the integral of 2 pi x, and then you take whatever this shape is, f of x, whatever curve this is. However, in this case, we have to mix in a little bit of washer type knowledge, where instead of just me taking a regular old picture and spinning it around, I have like an upper line, which I'll call RO, and a lower line, which I'll call RI, and we're going to find out what RO minus RI is, and then dx. Okay, so that's what we're dealing with here. All right, so our OR is 7. Our OI is root x. This lower limit is A. This limit is B. And we have all the information that we need to get started. So let's get started. We have, I'm sorry, I'm getting a pen. We have, let's move 2 and pi out here. Keep x right there. Lower limit's 0, upper limit's 4. Parentheses RO, my upper guy is y equals 7, so we'll just do 7 minus RI is root x, close it, dx it. Okay, so this becomes 2 pi. Distributive property says 7x. Well, I still have my integral. I can't get rid of that. Not yet. 7x minus, now this is x to the first times x to the 1/2, so we'll turn that into x to the 3/2 dx. Now let's integrate that. 2 pi comes along for the ride. The integral of 7x is going to be 7 over 2x squared minus the integral. Now remember when we do this, so we'll just kind of pull this aside. We're going to have 1 over 3/2 plus 1 x to the 3/2 plus 1, right? So this will become 1 over 5/2. 1 divided by a fraction is reciprocal. So 1 over 5/2 is 2/5 x to the 5/2. Look at me just barely fitting that in there. My limits of integration are still 0 and 4. But I have what I need to start using the fundamental theorem of calculus, so I'm going to do just that. I'm going to write this out, plug in 4 for every x, so 2 pi 7/2 4 squared minus 2/5 4 to the 3/2, close it. Just making sure I didn't miss anything. Minus that guy, plug in 0. Now let's use common sense here. 2 pi times 0 minus 0 is going to be 0, so that whole thing will become 0. Let's just get rid of it. So let's do a little bit of simplifying. All right, you can use a calculator if you want to, but I don't have one on me right now. So we've got 2 pi. 4 squared is 16. 7/2 times 16 is going to be 56. So 56 minus, I guess I forgot that guy right there, 2/5 times 4 to the 3 halves. I am going to use Siri for that one. Or is it 5 halves? 4 to the 5 halves. Yeah, it's 5 halves. What's 4 to the 5 halves power?
The answer is 32.
Okay. What's 2/5 of 32?
The answer is 12.8.
So this becomes 12.8. What is 56 minus 12.8?
The answer is 43.2.
And what's 2 pi times 43.2?
It's approximately 271.4336.
Okay. So that's shells for you. Not as crazy as some of the other things that we've done that look like discs and washers and stuff like that, but also not a ton of fun either. So unless I personally find it great. It's great. So thank you. Thanks for watching. Thanks for loving this stuff.